Hello students, this is Miss Dalton. Today we're looking at topic 3-2, which is more problems with constant rates of change. In example 1, we have Olivia and Chad were at adjacent typewriters while practicing their typing, which we really don't have typewriters anymore, so pretend like they're at computers. Olivia averages 45 words per minute, while Chad averages 36 words per minute. When Olivia started typing, Chad had already typed 90 words. So we're going to make a table, then we're going to write the function to show the number of words that each person typed. So you go back to your original 4 questions that you're going to ask, okay? So what is the independent variable and what is the dependent? Well, some of you might want to write the sentence that we've used. The number of words that each person types depends on the number of minutes that have gone by, okay? Because their average is per minute. So the number of words is going to be my dependent, so we're going to put that in the second position, because remember, dependent is your y. But we have 2 people that we're figuring that out for. So each one of these are dependent variables. They depend on the number of minutes, so this is my independent variable, and again, my independent variable could also be thought of as x. Okay, so let's fill in some minutes. So let's start at 0 because we want to see what we're starting with. And then after 1 minute, what's happening? After 2 minutes, what's happening? And then we're going to translate it into a function by using x. Well, Olivia, let's see what Olivia is doing. Olivia averages 45 words per minute. So this is Olivia. And Chad, well, he averages 36 words per minute. But remember, it says when Olivia started typing, Chad had already typed 90 words. So Chad has an initial amount of 90. So let's write Chad's first. He's going to start with 90 words, and then he's going to add 36 words per minute. So you can also think of that as 36 times m, or we can say x. But for this first one, our m or x is 0. So 36 times 0. So Chad initially starts with 90. Well, Olivia, she hasn't started typing yet, but we do know that she types 45 per minute, which at 0 minutes, we're going to just type in a 0, and that equals 0. So she's starting at 0, but Chad is starting at 90. Well, this is going to help us fill in the rest of our table. So now Olivia, for the next minute, she's going to type 45 words. So 45 times 1 is equal to 45. Chad has that original 90 words, and he's going to add another 36 words for that first minute. So 90 plus 36 is equal to 126. And then after 2 minutes, Olivia is 45 times 2. It's 45 for every minute, so 45 times 2 minutes. Now she's at 90 words. Chad had that initial 90 words plus 36 times 2 minutes, because 2 minutes have gone by. And that's going to equal 162. Okay, so you can see how you're going to develop your equation. For Olivia, it's 45 times every minute, which we're going to call x, and that's going to equal the y value that we got right here. Okay, Chad started at 90, and we're going to add 36 times every minute, x, and that's going to equal his y. Okay, so it says write a function for the number of words that Olivia has typed. So that's this equation right here. So y equals 45x. The number of words that Chad types, that's this equation, y equals 90 plus 36 times x. Okay, it says after 5 minutes, how many words have each of them typed? Well, we're going to have to figure out both of those. So for Olivia, y is equal to 45 times that 5 minutes. So after 5 minutes, she has typed 225 words. Chad, on the other hand, his equation is y equals 90 plus 36x. And so if I plug in 5 for x here, then that comes out to be 270 words. Okay, the last question. How many minutes will pass before Olivia has typed the same number? So see, there's that key word, the same. We've done this before. When we want to know when will two equations be the same, we have to set them equal to each other. So we're going to take the equation for Olivia, which was 45x, and we're going to set it equal to Chad's equation, which is 90 plus 36x. Okay? So we're trying to figure out when is the y value for Olivia and Chad going to be the same. So we would set both of those equal. Okay? So you might want to make yourself a note. We're going to take Olivia and set it equal to Chad's equation. And now we're just going to solve it. So we're going to draw our line. We're going to subtract 36x from both sides. So 45x minus 36x gives you 9x, and that equals 90. So we would divide both sides by 9, and x is equal to 10. So it takes them 10 minutes before they've equaled the same amount of words. In other words, it takes 10 minutes for Olivia to catch up with Chad. Okay, for the last example, I want you to read it, and I want you to try and set up your table on your own. So I'll pause the video, give yourself a couple of minutes to set up the table, and then press play again. Okay, check your table. One thing that you had to figure out before you could start was what Jay's initial distance was. It said that Jay got started writing 5 minutes before Bill, and he averages 0.25 miles per minute. Per means multiply, so I'm going to take the 5 minutes and I'm going to multiply it by 0.25, and that equals 1.25. So he started 1.25 miles ahead of where Bill was. Okay, so if I start the number of minutes at 0, 1, 2, Bill's distance 0.3 times 0 equals 0. And then J, his initial was at 1.25, and then we're going to add 0.25 times 0. And so that gives you 1.25. So check your table and make sure you did this right. And then this is going to give you your equations down here at the bottom. Okay, so let's use these equations to answer the question. So it says write a function for the number of miles that Bill has ridden. So that's y equals 0.3x. And then write a function for the number of miles J has ridden. So y equals 1.25 plus 0.25x. And then it said, who is ahead after Bill has been riding for 8 minutes? Okay, so 8 minutes. This represents your x value. So let's figure out where J is after 8 minutes. So J, after 8 minutes, it would be y equals 1.25 0.25 plus 0.25 times the 8 minutes, and that means that he is 3.25 miles away. Bill, after 8 minutes, y equals 0.3 times 8. So he's going to be 2.4 miles away. So who is ahead? Well, Jay, he's still ahead. Okay, and in the last question, how many minutes after Bill started will each have to ride before Bill catches up with Jay? So if Bill is going to catch up with Jay, then that means that their distances would have to be equal. So I'm going to have to set the two equations equal to each other. So if I take Bill's equation, 0.3x, and set it equal to J at 1.25 plus 0.25x, then I'd want to solve for x to see how long it's going to take. So I'm going to subtract my 0.25x to get the x's on the same side. Okay, this is going to give me a 0.05x, so use your calculator so you're not messing up the decimals. And this is cancels, so I have 1.25. So I'm going to divide by a 0.05 on both sides. That cancels, so x is equal to 25 minutes. So it looks like it's going to take them 25 minutes to catch up. Okay, that's it. Come to class with your notes filled out. Submit your WISC. Remember, it's either a 0 or a 100.